Python pals, this is Prof G, and I'm touched that you continue to watch our CircuitPython lessons, which is appropriate because we're about to work with Capacitive Touch using the Adafruit MPR121 STEMMA-QT Breakout board, which offers a touchingly large 12 capacitive touch pads, each of which is alligator clip friendly, and which can sense your capacitive presence or that of any other object that can convey capacitance. Now, conveniently, this board also has STEMMA-QT ports, so you can use this on any CircuitPython board that has a STEMMA-QT or Quick port. And I'll also show you we can use this when we wire a STEMMA-QT port to a CircuitPlayground or a Raspberry Pi Pico. We'll only have to change one line of code. First, I'll show you how we can set up and program this board. After this, I'll demonstrate what's called debouncing, so that each touch only registers one touch instead of repeated touches. Then we'll have a challenge where we'll also wire up a NeoPixel strip and flash different colors depending on the pad that's touched. So let's learn, my conductive companions. So this is the board we're using, and at the time that I'm recording this video, it costs less than $7. It also has STEMMA-QT ports on it. Now I'll be demonstrating this by wiring a STEMMA-QT port to a CircuitPlayground series board and also a Raspberry Pi Pico series board, but this can work on any board that has a STEMMA-QT cable wired to it or that comes with a STEMMA-QT port. Now, if you're using a CircuitPlayground or a Pico, I'm assuming you've already gone through the lessons to know how to wire the STEMMA-QT port to those boards. There's a lesson on each of these in the playlist. If you need a refresher, here's the wiring diagram. For the CircuitPlayground boards, the yellow wire to A4, also labeled SCL, and the blue wire to A5, also labeled SDA. Red power goes to any 3.3 volt, and black ground goes to any ground. For the Pico boards, the numbers are reversed. The blue wire goes to GP4, yellow wire to GP5, power should go to 3.3 volt out, and ground can use any ground. Now here's how we work with this board. First, make sure that you import the Adafruit _MPR121 library. Now we don't need the Touch.io library that we used when working with the CircuitPlayground boards, but when using the MPR121, we do need this library. Now remember, you need to have these libraries in your LIB folder on the board for things to work properly, and also remember, we usually import our board library in most examples we work with, and we also often use the time library. Then we'll create an I2C object, as we do in most cases when working with STEMMA-QT. In a prior lesson, we pointed out that you should use this code if you have a Pico board or a board with a built-in STEMMA-QT port. That's I2C equals board.allcaps stemma_I2C, open and close parens. But if your board isn't a Pico or doesn't have a STEMMA-QT port, so this includes the CircuitPlayground Bluefruit or Express, then try this code with just board.I2C, open and close parens. And if that doesn't work, consult the Adafruit Learn Guide for your board. Then we'll create an object that will hold all 12 touchpads, which I'll call touch_pad, and we do that with the Adafruit _MPR121 library. Use dot notation to access the MPR121 class, and we pass in the I2C object that we just created above. Then if we want to detect if a pad has been touched, we just refer to an individual pad via its index number, so we can check all pads using a for loop like this, looping through a range of 12, which will take us from index values 0 through 11, and if an individual touchpad's .value property is true, then that pad has been touched. So why don't we implement this code here, which will simply print the number of the pad being touched. I'm going to code in PyCharm. So we'll enter a comment, MPR121 _12 touchpads.py, and I'm going to import board and comma Adafruit _MPR121. Then I'm going to create my I2C object with I2C equals. Now those of you working with a Pico series board or a board with a built-in STEMMA-QT port, and nowadays that's most Adafruit boards, including Feather and QT series boards, you'll want to say board.stemma, all caps, _I2C, all caps, open and close parens. But I'm going to command / to comment out this line because I'm going to first show you the code running on a CircuitPlayground, and for that board, we'll still call our variable I2C in lowercase letters, and we'll set this equal to, and here's the change, board.I2C, all caps, open and close parens. So this should work on CircuitPlayground boards and most other boards where you have to wire up your I2C connection, but always check with your Learn Guide if you have problems, and Adafruit Discord is a great place to go for advice. Then down below, we'll create our sensor touchpad object. We'll call this touch_pad, and this is going to have access to all 12 sensor pads. Set that equal to Adafruit _MPR121, that's the library we just imported, dot, and in capital letters, MPR121, and in parentheses, pass in the I2C object we just created. And I always put in a print statement before while true to make sure everything's running, so I'll say print, and in between quotes, MPR121 code running. Then in my while true loop, make sure that you add your colon at the end, for I in range 12 in parentheses, add the colon in the end. That will loop through all 12 pads in the touchpad. Then we can check each pad individually if touch_pad in brackets I.value colon, if that is true, then that means that a pad has been touched. So below this, indented will print an F string with print, open and close parens, F, open and close double quotes, you touched pad number, and then curly braces, exclamation point, and in the curly braces we'll pass in I. So first I'll demonstrate this code running on a CircuitPlayground. I happen to have a Bluefruit. You can see everything's plugged in. You can see a little light goes on the board. That indicates everything's powered up and ready to go. Open the serial console, save, and ho, I've got an error, but you know what this is all about. Import error no module named Adafruit MPR121 means that we don't have this module in our library, but if you've been following along with our lessons, you have CircUp on your computer, and we can use this to help us out. First, since I'm in TO and PyCharm, I'm going to get back to the % prompt by typing Control-T, then the letter Q. Then at the prompt, I'll enter circup space install space -A, press return. Circup will take a look at my code. It will go out on the internet, find all the library files I need, and install them in my board's lib folder. If you don't have circup, you can find a lesson on how to install this in one of the earlier lessons in our playlist. Now we should be good to go, so I'm going to get back into TO, resave my code, and we're running. Let's experience the magic. So I've got my board here, and let's press pad 0, 1, 2, 3, 4, 5. Look at that, 0. All right, down on the bottom, I scroll my finger across. The one issue we have, though, is we're registering lots of taps in here. These pads aren't debounced. Remember, a debounced button only registers one press each time a finger is pressed on a different pad. But here, we're registering touches as long as our finger is down. That's why we have lots of repeated print statements as long as our finger's on a pad. Sometimes we don't want to report all those repeated touches. We just want to report one touch at a time. So to do that, we should debounce the pads. Now before we debounce, let me show you the code running on a Raspberry Pi Pico series board. So here's my Pico with a wired up STEMMA-QT port and the MPR121 plugged in. And at the % prompt, I should set my board to Raspberry Pi Pico W. That's the board that I'm using. Now I don't have to do this, but when I do, PyCharm will offer code completion and properly report errors related to the features for my set board. So to do this at the % prompt, we simply enter CircuitPython _set board space and then the name of the board. For me, that's Raspberry _Pi _Pico _W. Press return, no problem. I'll get back into TO and then back in the code, and I'm getting an error in this code because I haven't imported the library for my Pico either, but I'm going to use circup to fix that. Now when this runs again, I get an attribute error module object no attribute I²C, and that's because I'm using the code for the CircuitPlayground, not for the Raspberry Pi Pico. So I'm going to go up here and comment out the CircuitPlayground code and uncomment the Raspberry Pi Pico code. See how the I²C differs here? And then if I save and run my code, you can see the same code run. It's working as expected. The only change was the single I²C line. Nice. Now, on to debouncing. And actually, before I show you this, I'm going to save this as MPR121 _12 touchpads.py to our CircuitPython school folder. And always make sure you close that last tab so you're back at code.py. So here's a look at the code that we're going to write, and everything will change to get debouncing working is highlighted in red. So first we need to import the button class from Adafruit _debouncer. Whenever we use capital B button, that'll create a debounced button. So that button only registers one press or one release at a time. It won't send multiple presses as long as the finger is held down. That's what we had before. That's a touchpad that's not debounced. Now up here we create an MPR121 object. Remember, that's got 12 elements, one for each touchpad, with a value we could check to see if it was touched. But now we're not going to use this object to detect a touch anymore. Instead, we're going to loop through all of these touchpads, and we're going to create an element of a new list called pads that will create a debounced button using the button class, and each time we create that button, we'll pass in a touchpad so we can use that to create the debounced button. And for each button, we'll also set value when pressed equal to true. Now, we didn't need the second parameter in our lesson when we set up debounced buttons with the Pico, but we do need this second parameter with the MPR121, because these touchpads report true when pressed, whereas the default used for the button class is to report false when pressed. That's what you get with external buttons. So just remember, when working with touchpads, make sure you have this second parameter in the button setup, value _when_pressed equals true. You won't need that when you're wiring up standard external buttons. Now, by looping through each of the touchpads on the MPR121 and using these as an input for creating a new button for each touchpad, we're actually using touchpads to create a list of debounced buttons that use a touchpad for input. Next, down here, those of you that have worked through previous lessons with debouncing might remember we have to call this update method on every single button each time we want to check its state. So in this case, on every single pad. What that does is it gets the latest state of the button, whether or not it's been pressed or released since the last time it was pressed or released. And here we're only checking .pressed, although we could check .released if we wanted to check the released state too. Now if this is true, we'll print out you touched pad number, whichever one was touched. So let's modify our code and get debounced touchpads working. So first I'll change this comment to read debouncing _ MPR121 _ touchpads.py. Then we import our button class with from Adafruit _ debouncer import B button. I'll put in a comment above this code just to indicate that we use this to configure the MPR121 board. And down here I'll write a comment on the code we're about to write. We're going to create a pads list and fill it with buttons with a B using the touchpads as input for creating button objects. And remember, each button with a B is debounced. So first I'll create our empty list. That's going to be called pads. We'll set that equal to open and close square bracket. And that'll be a list which will hold our debounced pads, which are buttons. Then we'll use a for loop to go through all of those touchpads in our MPR121 object. So we'll say for, and what we call this T _ pad in touch _ pad colon. Remember, touchpad is this 12-element MPR121 object we created up here. And we'll go through this array 12 times, and we'll say pads.append. So we're going to create a new value and add it to pads, which is B button, and in parens, that's going to be the T pad, our current touchpad, comma, and then we'll also say value _ when _ pressed, and that should also equal T true. Make sure you end this with 2 closing parentheses. So when that's done, we've got a list called pads. Each element in the list is a debounced button. And in our while true loop, we had a literal, the number 12 in here. It would probably be better programming practice if we replace that with len for the length and in parentheses pads. If we ever change this with some kind of sensor that might have more or less than 12 pads, well, if it created its range based on the length of pads, we wouldn't have to change that literal 12 down here. The code otherwise does the same thing. Now, whenever we work with debounced buttons, each time we go through the loop and we want to check the button state, we've got to call the update method on a button. So we're going to say pads square bracket I close square bracket dot update open and close parens. This checks the current status of all of the pad buttons each time we go through our while true loop. Or another way to put that is it gets the current state of each debounced pad. Then in the if statement down here, we're not going to check to see if the touchpad I dot value is true. Instead, we're going to check to see if pads bracket I bracket dot pressed colon is true. And it's true the first time a pad is pressed. Now let's open the serial console. We'll save this. And you can see I've got to import Adafruit debouncer, but I'll Control-T, Control-Q, get to the percentage prompt and up arrow so that I can call circ up again. The debouncer file is loaded automatically over the internet into my lib file. Then I'll get back into TIO. Save. The MPR121 code is running. And let's try out those pads to see if they're debounced. 0, 1, 2, 3. Hey, look at this. So we don't have the repeated prints in here. It's only picking up one press at a time. This is looking great. Debouncing successful. And before we move on, let's save this with the comment name, debouncing _ MPR121 _ touchpads.py to our CircuitPython school folder. Make sure you close that tab, and let's keep going. So now that you know how to use your MPR121, I think it's time for a challenge. So in this challenge, you should hook up a NeoPixel strip to your board. We showed how to do that in a prior lesson. I'm going to use my Pico W board. And if you're using a CircuitPlayground board, why don't you use pad A1? You should know how to do that. Pico users, here's a wiring diagram in case you need a reminder. I'm going to use pin GP16 for my signal. Then import the Adafruit colors that are included in the Adafruit _LED _animations library. Also add our custom colors for indigo and violet. To make things easier, you'll find code for that on our CircuitPython tip sheet at bit.ly/CircuitPython-tip sheet. C and P in CircuitPython are capitalized. You'll see the colors list has 12 colors, one for each pad on the MPR121. Then, when any capacitive touch pad is touched, light up the same color at the same index value for that pad. So, touchpad 0 should light all of the LEDs in red, that's the first color in colors at index 0. Touchpad 11 should light the LEDs in white, that's the last of the 12 colors at the index position 11. Now keep the lights lit as long as a pad is being touched, but if no pads are being touched, then turn off all of the LEDs. I'm going to ask my students to perform two solutions, one with debounced pads, one without. Now the video at the right is showing a demo of what this should look like when it's running. You know how to do this. I have faith in you. Why don't you pause, give this a shot, and let's resume and compare answers. Let's change the comment up top to MPR121 Rainbow Touchpad. Now let's show solutions both with debouncing and without, and since my debouncing code is already on my board, we'll work with that first. So first, let's go get the color code and colors array from the tip sheet at bit.ly/CircuitPython, capital C, capital P, -tip-sheet. And aside for the storage issue that's right up top, these things are organized alphabetically. You can scroll down and find colors, or you can Command F, Control F and use the find command. And I'm going to copy all this code. That's from Adafruit LED animation.color through this colors array defined down here, but not the color wheel. Head back to the code, and I'll paste it in just before I configure my MPR121 board. I'll put in a comment, set up colors, then paste it in. And I'll clean up the extra spaces and put the colors array on 2 lines. And I've got to set up my NeoPixel strip, but I almost forgot. I've got to import NeoPixel first. I'll add NeoPixel to my import. And I'll set this up right below the colors array with strip equals NeoPixel.NeoPixel, capital N, capital P. And in parentheses, I'll put in the literals board.gp16, since that's what I'm connected to, comma, and there are 30 lights in my strip. Remember, if you have a CircuitPlayground board, you want this to be board.A1. Just as a reminder, if you're using a CircuitPlayground board, you also want to set brightness to 0.5, since they often have a hard time with full brightness on a NeoPixel strip. And also, when you run this, remember you're going to need your NeoPixel library and your Adafruit LED Animations library in your LIB folder. If you get the error they're not there, just use circup to install those files or drag them over manually. Now getting the lights to show is super easy. I'll just scroll down here to the bottom, and right after my print statement, I'll say strip.fill, and in parentheses pass in colors and in brackets I. That means when element I of the pads list is pressed, that if statement right here, I'm going to light up the strip with the colors list element I. Now you might be tempted to use else in here and just say else strip.fill and pass in black, but we don't want to do else in here. Otherwise, with debouncing, we'd continue to go through the loop and we'd turn things black right away. Instead, what we want to do is we want to perform another if statement. We're going to say if pads in brackets I dot released colon. That's triggered when the finger comes off the pad, and if that happens, we'll say strip.fill, open and close parens, and pass in black. Now I'll open the terminal. I have TO running. Click on save, and check this out. Moment of truth. Let's start touching some pads. Oh, and look at that. We're getting a rainbow to show up here. And these pads are debounced. Look at this. Different colors with every single pad. You stroke your hand across the edge there and you can see all those different numbers. Super rainbow popping up. So we've solved the problem using debounced touch pads. Now let's see if we can solve this problem without using the debouncing. First, I'm going to add _debounced to the comment up here, and I'll save MPR121 Rainbow Touchpad Debounced to the CircuitPython school folder. Then I'll close this tab and get rid of the debounced in the comment, and I'll load up the touchpad code that we wrote earlier that wasn't using debouncing. I named this MPR121 12 Touchpad, so I'm going to load that up in a separate tab. I'm going to highlight all this code, copy it, close this tab, head back to code.py, and I'll delete everything after the comment and paste in my old code, and I'll get rid of this extra comment up top. I'll make sure that I import NeoPixel here. Then I'll put in a comment to set up colors, and let's head back to our browser. We've already got the code that we need highlighted, so I'm going to copy that again, head back to my code, and paste it in. Then below this, I need to set up my NeoPixel object for the strip, so I'm going to call this strip equals NeoPixel.NeoPixel, capital N, capital P, and in between parentheses, it's going to be board.gp16, comma 30. CircuitPlayground users want to use a board.A1 and also set your brightness to 0.5. Now I want to light things up as long as something is being touched, but if one of the pads is not being touched, then I want to turn things black. And the way that I'm going to identify if a pad is touched each time we go through the while true loop is I'm going to create a flag called touched, and I'm going to set that equal to false initially. So every time I go through the while true loop, touched starts out as false. But then if I detect a pad has been touched, and that's what I do with if touched pad I.value, then I'm going to set strip.fill, passing in colors brackets I, but also I'm going to set touched equals to true, and that'll indicate that a pad is currently being touched. Then I'm going to outdent so that I'm even with the for loop. That'll make sure that the code I'm about to write doesn't execute until after I've gone through the for loop through its whole range. And this is where I check to see if I need to turn the pixels black. I'm going to say if touched double equals false colon. And if none of the pads were being touched during this pass through the while true loop, I'm going to say strip.fill in parentheses black. And just so you know, there's another way to say if touch double equals false. I'm going to comment this out with a hashtag in front, and I'm going to say if not touched, colon. That's the same as the line above, not just reverses whatever's in the Boolean to its right. So this if statement will be true if touched is not true, meaning touched is false, meaning none of the pads in the MPR121 were touched during this iteration of while true. You can use whichever statement you find most readable, but know them both. Now let's open the terminal. I've got TO running. Let's see how this works. Once again, moment of truth. Let's touch those pads. And oh, look at that rainbow. Now, of course, we're seeing the touch pads repeat because we're not debounced here, but this is working great too. And I'm going to save this to my CircuitPython school folder as MPR121 Rainbow Touchpad. Make sure you don't oversave the debounced one. This one is not debounced. And I definitely encourage you to go through and perform both of these solutions with debouncing and without debouncing because there are different techniques in each, and that'll help make you a stronger CircuitPython programmer. But Pythonista, I hope you feel good about those skills. You've now got the MPR121 in your utility belt of tricks. And you know how to debounce those touchpads. Now use that skill to make something awesome.